Hello, Algebra 1. Welcome to our second mini topic covering square roots. This is part 1, simplifying radicals. We have done some of this already this year. When we did quadratic formula, we had to do some simplifying radicals. So let's revisit what we've done already. Right? So say you had to simplify the square root of 72 and answer it in simplest radical form. Well, the first thing I'd ask you to do is plug that into Desmos. So let's do that real fast. Let's plug it in Desmos. So remember, you do square root down here, square root of 72. Oh no, it's a decimal. So now we need to start breaking it apart into its prime factorization, right? You could use perfect squares, but I'm not sure if you know your perfect squares. If you do, go for it. But if not, prime factorization always works, right? So trying to give you a foolproof way of doing it, right? So if I'm trying to do the square root of 72, okay, so I'm going to break down 72 over here. So remember the list of prime numbers. So 2, 3, 5, 7, 11. I would just try those. If it doesn't work, it's probably a prime number. So 2 does go into 72 because it ends in an even number. So if I do 72 divided by 2, that's going to give me 36. So 2 is prime, 36 is not. So I'm going to cross off the 36 and break it down. Now, as I was mentioning, if you know your perfect squares, 36 is a perfect square. The square root of 36 is 6, so 6 squared is 36. So if you know that, you could be done right away, and I'll show you that at the very end, all right? But for those who don't, I'm going to take 36 and divide it by 2 again. That's 18. 2 is prime, 18 is not. 18 divided by 2 is 9. 2 is prime, 9 is not. 9 does not get divided by 2, but it does get divided by 3, and that's 3 and 3, and those are both prime. So these are the 5 prime numbers that make square root of 72. So I'm going to write this down as 2 times 2 times 2 times 3 times 3. And with square roots, remember there's a hidden index 2 right there. So anything that is squared can come out of the square root. So I'm going to group my 2's by 2's. So I have a 2 squared, and then this 2's by itself. And then I'm going to group these 2 3's with a squared. So then anything squared comes out. So this 2 is squared, so a 2 comes out, that 2 squared goes away. This 2 stays inside. This 3 is squared. It comes out. Notice I put multiplication, and now it's gone. And now the only thing left inside the square root is this lonely 2. And then we do 2 times 2, or 2 times 3, which is 6 square root of 2. So now back to here, right? If you can recognize your perfect squares, and again, feel free if you know your perfect squares to do it this way. If you can recognize those, then you could do 2 times 6 squared. And or 2 times 36, and the square root of 36 is 6. Or because the 6 is squared, the 6 comes out and the 2 stays in. And you get the same answer no matter what. All right, so today the big idea is the following, right? If we have a variable or anything squared and it's inside of a square root, remember because of this index being a 2, they're going to cancel and your x is going to pop out. And that's what we're doing today. Okay? So we're going to do problems involving numbers and variables. So let's take a look here. Okay? All right, question 1. Simplify, assume that all variables are positive. You can ignore that second talk. That's for another day. So this is our problem here. So the first thing I would do is I would go ahead and take the square root of 75 and plug it in Desmos. So let's do that real fast. Right? Let's make sure that it's not a perfect square. So right here, I'm going to go square root of 175. And it's not, it's a decimal. Bummer. So I'm going to come back here. I know I have to break that down. So I'm going to focus on the number first. Right? So let's break down the 175 first. So I know that it ends in 5. So I know that 5 goes into 175. And when I take 175 and divide it by 5, I get 35. 5 is prime, 35 is not. 5 goes into 35 again. It goes into 35 7 times. 5 and 7 are both primes. Remember the list of primes. 2, 3, 5, 7, 11. So this is my prime factorization for 175. It's a 5 times a 5 times a 7. Right? Now I can throw in that x to the 9th right now, all right, but I'm not going to touch it, right? So these two 5s represent a 5 squared times 7. You got that x to the 9th right here. So this 5 is going to come out. It's gone. The 7 stays inside, and there's what we have so far. And now how are we going to attack this x to the 9th? Well, I'm going to show you the expanded version first, and then I'm going to show you the shortcut, right? So we want as many x squareds as possible. So it's just like subtraction, right? So x to the 9th would be x squared, that's 4, right? If I add them, 4. X squared, that's 6, times x squared, that's 8. And now we have one x left over, x to the first. So it's an x squared, an x squared, an x squared, an x squared, and then one measly x. If you add those together, you do get 9. Okay? So notice that 1, 2, 3, 4 x's are squared, right? So 1, 2, 3, 4 x's will come out. So you would have x, or 5, and you would have times x, times x, times x, times x, a 7 inside, and then you'd have one x left over. And these 4 x's, you're multiplying them, so you would add the exponents, you would get x to the 4th. So your final answer here would be 5x to the 4th on the outside, and then inside, square root of 7x, and that'd be simplified. Now, an easier way to do this with the x to the 9th, and I'll do that over here, is you know that this is an index of 2. So take 9 and divide it by 2. Now when you do that, 9 goes into 2 4 times, right? 4 times 2 is 8, and then you're going to have a remainder of 1. So this will be the exponent of your x on the outside. This will be the exponent of your x on the inside. So x to the 4th is right here, and x to the 1st is right there inside the square root. So you can always just divide the exponent by 2. And we'll do that moving forward. But here's your simplified version of this problem. All right, next. Very similar question here. It says multiply now. And we're going to assume that all variables are positive. So now we have a rule that we can use doing radicals or square roots. If you have a square root of a times a square root of b, you can put them inside one square root of a times b. Right? So we can use this idea, right? So we can do the square root of 6. Now I'm going to put the 18x times 18 times y to the 7th times y, right? All of that's inside one big square root. So now what I'm going to do first is I'm going to take the square root of 6 times 18 in Desmos. So watch this. So I'm going to do the square root of 6 times 18. Now, it's not a perfect square. If it was a nice number, I would not do any simplifying right now, but it's not nice. So we're going to break the 6 and 18 down. Notice I didn't multiply them out. The reason I didn't multiply them out is because you would just get a bigger number, right? I'm going to break these down into smaller numbers. Why make them bigger, right? So over here, I have my 6. How does 6 break down? Well, 6 is 2 and 3, and that's it. And then I have 18. How does 18 break down? Well, 2 goes into 18 9 times. 9 is not prime. 3 times 3 makes 9. So here are my 1, 2, 3, 4, 5 prime numbers that will make 6 times 18. So inside my square root, I have 2 and 2, and then I have 3 3's. And now if I combine a y to the 7th and a y to the 1st, add 7 and 1, that's y to the 8th. Okay, so these two 2's are squared. The first two 3's have a 3 squared, and then you have 1 3 left over, and we have a y to the 8th. So remember, there's a hidden 2 there, so anything that's squared comes out. So this 2 will come out, the 2 squared's gone. This 3 will come out, the 3 squared's gone. This 3 stays inside, and now with this exponent of 8, I take 8 and divide it by 2. 2. And 8 divided by 2 is 4, and that's going to be the exponent of the y on the outside. Notice there's no remainder. The remainder is 0, so there's no y's left inside. So these y to the 8 comes out as a y to the 4th. And what's left inside is that lonely 3. Multiply 2 times 3 to get 6. 6y to the 4th times the square root of 3. And there's your answer. So again, lots of number play here in this lesson. Okay, last problem here. So this is going to be just one video. So now it says use the Pythagorean theorem to find the unknown side length of this right triangle. So let's review what the Pythagorean theorem says, right? If I have a right triangle, okay, the Pythagorean theorem says if you add one leg, so this is a leg, to the other leg, this is a leg, and you square them each, right? So a squared plus b squared, that's going to equal the hypotenuse, which is this c squared, right? So again, this is called a leg, this is called a leg, and this is called the hypotenuse, H-Y-P, hype. Get hyped about the hypotenuse. So we have a squared plus b squared equals c squared. This is the formula we're going to use to solve this problem. Okay. So in this problem here, I'm going to label the hypotenuse x, right? So this 20 is my A, this 15 is my B, and this x is my C. So if I use Pythagorean theorem, a squared, that's 20 squared, plus b squared is 15 squared. That's going to equal c squared, which is my x squared. You can type this in the graphing calculator all at once, and I'm going to do that on a different screen. I'll finish the problem on a different screen. Okay, so let me show you how to do that. So if we go to Desmos, and we do separately, right? So we're going to do, oh no, I'm sorry, we're going to do this, 20 squared, sorry, plus 15 squared, right, separately. Okay, so we do them individually, but we add them together. That's 625. So 625 equals x squared. And now on the very first slide, if you have to get rid of a squared, the way you do that is you take a square root. Now we're going to learn in the next section that you should have two answers when you do this square root, plus or minus, because of how x squared behaves. But this is a real life problem involving a real triangle. We don't want negative numbers, so we ignore the plus or minus here. And now I'm going to type in the square root of 625 and see if it's nice. So I'll do it down here, square root of 625. And yes, it's a perfect 25. So your value of x, your missing side, is 25, and that's the answer here. So we will do some Pythagorean theorem in this lesson and the next lesson because it's a good application of squares and square roots. All right, great job. Thanks for watching.